Hello.
Good morning, sir.
Hi. Good morning, Naren, and good morning to everybody else who's joined in today as well. I'll just introduce myself. My name is Hubert, and I own a company called schoolbox.com, and I will be tutoring you through your 10th grade math, all the portions. I think we've already finished a few classes, 8 classes to be specific, and the remaining classes we'll be doing through till the end of April, just before your class 10 exams would start. I'm already familiar with Yash and Naren, but the rest of you, I think most of you are from Baldwin's.
Yes, sir.
Okay. So there are videos that are already there on the link provided. So you can go over the videos, and if there are any doubts at any point of time, don't hesitate to stop and ask me. Or if you have any doubts while you're studying during the week, you can send them to me via email or WhatsApp, or you can even bring those doubts to the classroom and we'll try and address them. Okay. All right. So I hope everybody is in the class and we can start now. Um, Last week we were doing a topic called arithmetic progressions, and I think I don't know if all the doubts were cleared in that. Any more doubts in that, Zenetta, Naren? You guys were there in last class.
No,
Any
sir, no
doubts?
doubts. I
You're
don't have
okay with
doubts.
that?
Yes, sir.
Yeah. Just a minute. Someone's joining. Okay. So, is there a topic that you'd like to work on today? Anybody?
The tangents and intersecting chords.
Tangents and intersecting chords. Okay. Okay. Are there any doubts? That's Yash, right? Okay. Any doubts in that topic, or just want to go over the topic?
I just want to go over the topics now.
Okay. Can we do that? Is everyone okay with that? Just a quick look at tangents and intersecting chords. Yeah. Fine with that.
Yes, sir.
Okay. So I'm going to use the whiteboard. And yeah, for those of you who don't know me, I think few of them have joined me. The videos are available online, all right? So you can go over the videos and just catch up on the previous lessons. Okay. So today we'll look at tangents and intersecting chords. So this year, due to the pandemic, a lot of the portions have changed and in fact have been reduced. Your teachers would be getting latest updates on the portions, and hopefully they've passed on that information to you and you guys are aware of the portions, right? For sure. And I think Naren and Zenetta, Yash have been updating me about the portions, and because they keep changing it quite often. Okay, so just let me know if I'm doing something that's out of the portions. I'm quite aware of the portions, but if I do slip up, please let me know. Okay.
Yes, sir.
All right. The first thing that you learn in the first thing that we learn, a simple theorem that we learn with tangents and intersecting chords is that if you have a circle here with the center, and there's a tangent that intersects it. A tangent would touch a tangent is a line that touches either a curve or a circle at only one point. All right. And so imagine that this tangent is AB, and this is touching the circle at a point P. And let O be the center of the circle. So OP is the radius of the circle and AB is a tangent. So this is one theorem which says that a tangent is perpendicular to the radius at the point of intersection, at the point at which the tangent intersects that circle. Okay. So this angle is 90 degrees, basically. Both of these angles are 90 degrees each, is what the theorem says. Okay. So it could be anywhere. It could be anywhere. So let's say this is another tangent, and at this particular point, as the tangent touches the circle, so this is 90 degrees as well. Okay. So wherever the tangent touches the circle, from that point, if you draw a radius, the tangent and the radius are perpendicular. This is a very simple theorem, and it's the first theorem that you get to learn in this topic. Okay. If there are any doubts, like I said, don't hesitate to stop and ask me. All right. So we can put this aside for the time being and move on. I'll take you to the next page. If anybody wants to take a screenshot or something like that, I'll just give you a few seconds. And then we'll go to the next page. I'll just write this down as well. Theorem is that a tangent at any point of a circle and the radius through this point are perpendicular. Right? Perpendicular means it's 90 degrees. Okay. So make a note and give me a few seconds. I'll move to the next page. This page is existing. I'm not erasing it. I'm just switching to another page. Okay. If anybody wants me to go back and you want to take a screenshot or anything, let me know. Okay, which brings us to the second theorem with tangents and circles. Let's say there's an external point called P somewhere, all right? Let's just assume that there's an external point P somewhere here. Outside the circle, external point is outside the circle. And from P, if you draw two tangents, basically there can only be two tangents maximum drawn from this point P onto the circle. Okay, both of those tangents, let's call it PQ and PR, both of those tangents, let's say this is the center of the circle, are perpendicular, and more than that, they are equidistant, or they are of equal length. So this theorem says that PQ would be equal to PR, right? O being the center of the circle, PQ is equal to PR. Okay.
So basically they're the same length, PQ and PR. Hello, sir.
Pardon me?
So basically, we are telling that the length PQ and length PR are the same.
Yeah, yeah,
Okay,
yeah. And only two tangents can be drawn from this external point P.
fine, sir.
Okay. From the external point P, only two tangents can be drawn, and those two tangents are equal. We'll take this a little forward over here itself. Okay. So let me take this a little bit forward and draw a line that joins O and P. Okay. Draw a line that joins O and P. Okay. So now we have two triangles. Okay. We have two triangles, triangle POQ and triangle POR. So is everybody following this? If someone isn't following, just stop and ask me a question, okay?
Okay, sir.
Just checking. I got a message from someone, I think, I'm not sure, but by the name of, it says Dimple, uh, saying, sir, let me in the class. Dimple or Dimple's daughter, are you in the class?
Yes, sir, we are in the class.
Okay, all right. So there are two triangles, POQ or POR, okay? And they are right angle triangles by virtue of their angles being 90, one of those angles being 90 from the first theorem. That's OQ and PQ are perpendicular to each other. Also, we can try and prove congruency. You guys are familiar with congruency? We'll try and prove that these two triangles are congruent. Okay? We know from the theorem that PQ is equal to PR. We just said it from the theorem, right? Because from an external point P, the two tangents drawn onto the circle are equal in length. So that tells us that PQ is equal to PR. Okay. Also, PO is equal to PO, which is common, right? PO is equal to itself, which is common. You've probably gone over that in congruency. Right? So that red line basically is equal to itself. And lastly, the angle, the two red angles, right? PQO and PRO are equal. Okay. And that's because they're both 90 degrees. This is from the theorem. So just repeat that. The first point that we know for, in our quest to prove congruency is that PQ is equal to PR. The second thing is PO is equal to PO because it's the same line. And lastly, PQO is equal to PRO. From the previous theorem, we know that that angle is 90 degrees because it's the point where the tangent and the radius meet. Okay, I've just
Sir,
labeled
can
that as
we
well.
say OQ is equal to OR because the radius of the same circle?
You can say that as well. Yeah, they're both radii as well. That's another point. So OQ is equal to OR. Yeah, yeah, you can say that as well. Very good. Okay, so if we hadn't said that, if I hadn't said OQ is equal to OR, and I just stuck with these three, right? Um, I could say that it's congruent. Let's include this as well, and let's take out one of these.
I
Let's
think
take
the
out
second one, sir, because then you'll able to prove SAS, side angle side.
you can take out the angle and say it's SSS as well. Okay, triangle POQ. It's the easiest actually. POR by triple S. Is that okay, guys? I'll remove this point. I think I'll go with what Yash has said. It's a touch easier. Okay, fair enough. So you know that if you know that these two triangles are congruent, then then all the three angles of one triangle are equal to the three angles of the other triangle, right? Which means that I'm going to use colors for this, which means that this angle will be equal to this angle. This angle will be equal to this angle. And of course, the red angles are equal. And let's also draw the lines in some color. These two are equal to each other. Okay. And lastly, these two lines are equal to each other as well, which are radii, it's obvious. So all these three lines and all the three angles are equal to each other. And that's a big takeaway from this, especially for your numericals. Okay, they could ask you angle measures, and you know that from an external point, when two tangents are drawn, this is what happens. These are the two triangles that are formed, and these angles are equal. So you can make a
So,
note.
so you have to every time prove congruency to show that the blue angles are equal.
No, not necessary. Not necessary.
Okay.
You can assume that, you can state that as a fact, saying that since the triangles are congruent, that should be okay. Since the two triangles are congruent when from an external point two tangents are drawn. Okay, so you guys are done with this. Can I move to the next page? Anybody still writing?
Yes, sir. 1 second.
Yeah.
Yes, sir, I'm done.
All right. Okay. So we'll move on to the next theorem. And if two circles touch each other, let's say they are of different sizes, then they have a common tangent like this. They have a common tangent like this. Let me just draw that tangent properly. Something like this. Okay, they have a tangent, common tangent between them. And let's say that the centers of these circles lie here and here. Okay. So the theorem says, and I'll write this down. I'll label the circles also too. So the theorem says, if two circles touch each other, if two circles touch each other, the point of contact, that's this point, let's call it P, and let's call this as AB or something like that. Okay. If two circles touch each other, the point of contact lies on the straight line through the centers. Let's just call this as PQ, the tangent. So it says, so just to repeat what the theorem says, it says that these two blue circles are touching each other. The point of contact, that's the, I'll mark that in a slightly different color, say pink. Okay, the point of contact lies on the straight line through the centers, right? So the point of contact lies on AB. This point P will lie on AB, okay? If AB is here, again, let me just draw that separately. And the two circles would touch. This point P will not be here, or this point P will not be here. It will be on the that line, on line AB is what it's trying to say. Okay. Yeah, is that fine? So that's all the theorem's trying to say. So these two circles could touch internally as well. So right now they're touching externally, but one circle can be inside the other circle also. Okay, like this, like this. I'm just going to draw it a little smaller. Okay, so one circle inside the other, and the tangent, that's somewhere here, somewhere like this. Okay, and again drawing their centers, let's say here and here. Okay, that, so it would tell you that the point P, which is in contact, this point here would lie on the line that joins its centers. Let's make that RQ. Yeah, I hope that's okay. Can I move to the next page?
Yes, sir.
Yes, sir.
Yes, sir.
I haven't touched upon any of the reduced portions, right? I'm doing the further reduced, right, guys? Does anybody feel that I'm doing anything
Yes,
from?
sir.
Yes, sir. This is
Actually, sir, we do not have this theorem.
Oh, really? Okay. I thought we did, but this is Kushali, right? Okay, this theorem isn't there, is what you're saying?
Yes, I just checked on the official website and it's not there.
You did? Okay, okay, fair enough. Just let me know, like I said at the beginning, because these things change every now and then, but okay, fair enough. I might not have picked that up. Okay. So there are, okay. In this chapter, are there any more theorems that we need? I think we need the alternate segment theorem, right?
Yes.
Alternate segment theorem. Any other theorems? There are two more. That's the PA into PB is equal to PC into PD. Is that there?
No, sir, we have only three theorems, the previous two that we've done and the alternate segment one.
An alternate segment. Okay, you're sure about that, right?
Yes.
Okay. So I'll give you a phone number to the rest of the students. If in case it does come, then they will make sure that they text you until you start crying. All right.
Yes, sir, but I'm pretty sure it's not there because I just checked on the website.
I'm not going to give anybody's contact details to anybody. All right. Okay. All right. So this is fine. Is this okay?
Yes, sir.
We can move on, guys. Naren, Yash, Zeneta, and all the
Yes,
others.
sir.
Yes, sir.
Yes.
yes, sir.
And my audio is clear. Can you guys hear me reasonably clearly?
Yes, sir.
Yes, sir. Yes, sir.
Okay, now we come to the alternate segment, and this is a theorem that a lot of children find tricky. Okay, but it's actually not that bad if you look at it in a particular way. And I'll try and explain to you as best as I can what that particular way is. Okay, let's say there's a circle with a center O and a tangent that is at the base. Try and make that tangent. Okay. Okay, so this tangent touches the circle at some point, and I think your textbook, if I remember clearly, says A. The tangent is PQ, and let's say this makes an angle. Let's say there's a chord. You guys know what a chord is, right? I'm sure you're familiar with the basic terminology.
Yes, sir.
Okay. So let's say this chord is AB, and this chord makes an angle. Okay. Now, the alternate segment theorem tells you that if you use AB, all right, if you use AB and make an angle inside the, make a triangle, sorry, inside the circle. Okay, so from A, draw a line onto the circumference. From B, draw a line onto the circumference. That angle will be equal to angle BAQ. Okay. So that's a good way to visualize it. All right. Is this easier now? And let's call this C. So angle BCA is equal to angle BAQ by alternate segment theorem. Okay, so visualize it this way. Think of the tangent PQ, a chord that makes an angle with that tangent. And from that chord, basically draw two lines that intersect at some point on the circumference. And the angle that's formed there will be equal to the original angle. I think in your textbook, what they've done is they've drawn two of those, right? And that's where it looks slightly confusing. But now if I were to draw two, okay, let's say I draw this angle, I'll make it up. So this angle again, I've got to make sure that the triangle points in the other direction, okay? That's one thing. The triangle doesn't point back in the same direction where the angle is. So the angle here, just is on the left side of BA, right? It's on this side of BA. So my triangle has got to be on the opposite side, which means it's got to come here. I'm just going to draw that. Give me a few seconds. It's got to be here. And this angle now is equal to that big blue angle that I've drawn. Yeah, is that okay? Making sense now? Just make a note of this. Also, angle, let's call this D. BDA is equal to angle BAP for the same reason. So I hope that this has made it a little bit easier for you, the alternate segment theorem. Let
Yes,
me
sir.
know if it's made it difficult for anyone in this class. If that's so, then I can think of another way of explaining. Has anyone found it a little harder than it was before? Or not understanding it, maybe want me to explain again? Anyone? Let me know, all right? And like I said, the videos are available for this session. You can watch it later as well. And you know my phone number and you know my email. Don't hesitate to drop me a problem in case you do encounter any difficult problems. So I'm offering that as well. Okay.
Sir, could we work out some sums now?
Yeah, we can do that. Is everyone ready to move on? Anybody still writing?
No, sir.
Anybody has any problem in this particular problem? By problem, many times I mean sum that you want to work on. Any doubt, question, anything at all that you want to do first? I'll do those questions first. Any doubt questions are there? Because mostly the doubt that one person has, many times it will also be a doubt that a few other children would have. So if there are any doubt questions, I'd like to work on those first. Then I'll pick a few that I think are important. Okay. Anybody?
In
Any
exercise
particular question?
18A, the ninth one.
Pardon me?
In exercise 18A, in the textbook, the ninth
Okay.
one.
Sir, that
18A,
sums out of syllabus.
ninth one. Okay. I have, okay. Okay, is that out of
Sir, that
syllabus?
sums out of syllabus. Yes, sir.
Sure, right? Okay. Yash, I believe that's out of
Yes, sir, sir.
syllabus. So you can celebrate. Any other sums?
Sir, 18A, the 16th one.
18A, the 16th one. Okay, let's just quickly look at that. I think there are some that are online. 18A, 16th one. Is that the one with the circle inside a right angle triangle?
Yes, sir.
Okay. Yeah, we can look at that. That's in syllabus, right, guys? Let me try and draw that out.
Yes, sir.
So I have it online. I'll just take a screenshot of this. Okay, hang on, guys. Can I do that and put it up? Okay, I think I can. All right, just give me a few seconds. Okay, I'll use Microsoft Paint for this. I'll move to another screen. Yash, this is the one, right?
Yes, sir.
Okay. Yeah. So for this, what the theorem that we'll be using is that from an external point, let's say A, the two tangents that are drawn, we just learned that right now, right, are equal in length. Okay. So that'll work for all of these points. Okay. So an external point C, these two tangents would be equal. And the same with the point B as well. These two tangents would be equal. So all of those, the orange lines are equal to each other, the green lines are equal to each other, and the blue lines are equal to each other. You can see those, right, on screen?
Yes, sir.
Okay, so we have some measures that are given to us. Okay, so AB is equal to 12. That's given to us here. That's the entire length, okay? And calculate the value of x, that's the radius. So this is also x, okay? This is pretty much a square because this is 90, this is 90, and yeah, I think we can safely say that this is a square. This is x and this is x. So all of these four sides are x. 13 is AC, okay? Now using Pythagoras theorem, we can calculate the length of BC. So BC squared, just move that to the side. So BC squared is equal to AC squared minus AB squared. Okay, so Pythagoras theorem tells us that the sum of the squares of two smaller sides of a right angle triangle is equal to the square of the hypotenuse. Okay, so from that we've derived this. I'm sure you guys are familiar with Pythagoras theorem, might have studied that ages ago. Okay, so BC squared is equal to AC squared. AC is 13. 13 squared is 169. Take away 12 squared, which is 144. So BC squared is 25, which makes BC as 5 centimeters. Okay, so BC is 5 centimeters. The whole thing is 5 centimeters here. Now, these lengths, the green line, CM, okay, CM is 5 minus x because the whole CB, BC, the whole thing is 5, right? And we take away a little part from this called x. So whatever remains is 5 minus x. Okay, so this part is 5 minus x. In the same way, NC, okay, let's not look at NC first. Let's look at AL. In the same way, AL, so AB is 12 centimeters and AL will be 12 minus x. Is that okay? Yeah, right, guys? Got it up to here? Any questions? Just let me know. Please don't hesitate. Yeah?
Yes, it's clear.
Okay. Now, you know that um, these two lengths, I'm just gonna, one moment. So AC, right? Inside AC, there's AN and NC, correct? Inside AC, let me just, so this line AC is made up of this orange bit, correct? And we just said that the orange bit is 12 minus x. So if this is 12 minus x, then this will also be 12 minus x. You agree with that? 12 minus x, okay? And we said that this NC, green line, over here is 5 minus x. So this should also be 5 minus x, right?
Yes.
So this bit, the orange bit, plus this green bit together should be equal to 13, right? Is that fine? Everybody clear with that? Any doubt, just don't hesitate to ask, okay? So
Yes, sir.
that AC line 13 is, let's write that down in a way as AC is equal to AN plus NC. Okay, and AC is 13 is equal to AN, which is 12 minus X, plus NC, that is 5 minus X. Okay, so from here, it should not be too difficult to solve. 13 is equal to 12 plus 5 is 17, minus X plus minus X is minus 2X. So moving the 2X over to the other side, switching places with 13, 2X this side, 13 that side. So you get 2X is equal to 17 minus 13. 2X is equal to 4. Therefore, X will be equal to 2 centimeters. I think that's all they wanted from us.
Yes, I got it. Thank you, sir.
Okay, is that fine, guys?
Yes, sir.
Yes, sir.
The note, let me know, give you a minute, a few seconds to write this down. You can even take a screenshot. It's an important sum, though, I must say. It's appeared in the ICSE a few times. Okay, so I'm going to move on to the next question. Is there a question, any doubt, anything at all? Any one of the children?
Excuse me, sir.
Yep, go ahead, please.
Sir, please can you do the 20-second sum?
20-second sum in the same exercise, A.
Yes, sir. Yes, sir.
20-second sum. That's PT is a tangent to the circle at T. Something like that.
Yes, sir.
Calculate CBT, BAT, and APT. That's the one, right?
Yes, sir.
Don't know. This is not given fully over here. Looks like something's missing. Okay, let me just check. I'll just bring that problem onto the whiteboard. I think in the question something's missing. I have a feeling. Let me just know, okay, because you're using the textbook. Just confirming, Yash, your doubt was cleared last time. Everything okay?
Yeah, sir. Yes, sir.
All right. So yeah, I think something's missing here. It says if and there's no continuation. Is there something there? And I think this question came from Namita and Naina.
Sir, they are told that if ABC is equals to 70 degree,
One moment, let me just write that down. If ABC is equal to
70,
70 degrees. Okay. Angle ABC is 70 degrees.
and
Okay.
if
One.
angle ACB equals 50.
ACB is 50. Okay. ABC is 70 and ACB is 50. Oh, okay. That helps. So this is 70 and this whole angle is 50, right? Okay, great. So yeah, that was missing. Okay, you've got to find CBT, BAT, and APT. Okay. Okay, so how do we do this? Anybody have any suggestions, or do you want me to start? Okay. Yeah. Okay, we can draw a line here. One moment, yeah. We'll join BT. Okay, now I'm going to boldly go out and say that CBT is 90 degrees. Can I say that? Angle CBT is 90 degrees. So I'm making a claim that this angle, the red angle, is 90 degrees. Can I say that? Anybody? Why did I say that?
Sir, angle in the semicircle?
Yeah, but how do I know it's a semicircle? How do I know that?
So because CT is forming 90 degrees with the tangent.
Yes, that's right. Because this angle here is 90. So it means that, let's make this as O. Suppose it was OT would be the radius by the inverse of that first theorem that we learned, that a tangent, in this case PT, and OT, the radius, is making a 90-degree angle. Okay, so it's confirmed that OT is the radius. And if you extend OT, straight line, that's the diameter. So that is the semicircle. And you guys are right. You guys all are right. Because CT is the diameter, that's why CBT is 90 degrees because of angle in a semicircle. Well done. Angle in a semicircle. Okay, so CBT is 90 degrees, which makes this angle as 20 degrees. Right? Okay. The children who asked me this, are you guys following?
Yes, sir.
Okay. So CBT is 90. That's the first part done, right? Then BAT. Okay, let's try and join that line, BAT. Yeah. So how do you find BAT?
So due to cyclic orbital property, we know that CAT is 90.
Yeah.
The full angle is
Okay.
90.
So that makes the entire angle CAT as 90 degrees. Fine. Okay. And then what do we do from there? Yeah. I don't know if you can spot this. It's a little tricky to spot,
So
guys.
is
But if
angle
just from
ACT
circles, yeah.
20? Is angle ACT 20?
Yeah. That's what I was just coming to. So this angle here, the 20-degree angle, okay, this, just keep your eye on this chord, okay? And the angle from that segment would be equal to the angle in the same segment, but at a different point. Okay, so the base is the same. Can you see that, guys? So that's why this is 20 degrees. That's why this angle is 20 degrees. What I'll do is I'll just draw it a little bit bigger over here. Then we can erase it. It looks clearer. Okay, so this line here, that's AT. And the angle that's drawn from here onto this. Okay, so this is the arc that it's coming from. This is the arc where that's coming from. From the same arc, if I draw another line, another angle somewhere else, that should also be the same, right? You got it now? This would also be 20 degrees if this is 20 degrees. Okay, so that's how we arrived at that being 20 degrees. That's ACT. Okay. And TCB then would be 30 degrees, right? Just erase that. If this is 20, then this would be 30. Is that fine? Because that whole angle was 50, so it's split into 20 and 30. All right. Okay with that? Okay.
So then angle BTC is 60.
Angle
BTC.
BTC is 60. BTC is 60. Yeah, it would be 60 because it's the triangle, right? The
Yeah, so
triangle
angles and properties.
has two angles, 90 and 30 already. So the other is 60. That's fine. Okay, we are looking to find BAT though.
Yes, so angle BT, whatever it's not marked over here, will be 30.
Call this X. Okay, this is
Yeah,
30. Okay, fine.
so angle BAT will be 30 because of that
Very good.
segment.
Very good. That's well spotted. Did everybody realize that? What happened there? We've come to that alternate segment theorem. Okay. We've used the alternate segment theorem. So this angle is 30. Okay. And this is that segment. I've drawn two lines to the circumference from there on the opposite side, and that's why this is 30 degrees. Is 30 degrees. Okay. All right. So the last one is APT. Yep. Anybody?
Angle ATP is 20.
AT?
P is 20.
ATB is
ATP,
20.
man. Sir, ATP.
ATP, that's this little angle is what you're saying?
Yeah.
Okay, is
20 because of alternate segment theorem. Angle ABT is equal to angle ATP.
angle? Yeah, that's fine. That's 20 degrees. Very good, because this angle is 20. Is everybody following this? Is anybody not following it? Do you want me to repeat? Don't hesitate to ask me, all right? It's better that you ask me. Anybody wants to repeat, you can always say, can you please repeat? I'll be happy to repeat that. All right. So what I think Yash said was that because of alternate segment theorem, I'm just going to redraw that. On this side, this chord is making an angle which will be equal to, you join those two lines, this angle. So that's how this was 20 degrees. Okay. Okay. Then
So then PB is a straight line. So
yeah,
angle TAP will be 150. No.
yeah, that's clear as well, right? Because this line is a straight line and these two form a linear pair. This is 30 degrees. So this is going to be 150. So in this triangle now, in this triangle, there's two angles, 150 and 20. So the remaining angle will be 10 degrees. Okay, that's APT is 10 degrees. So everybody follow that? Any doubts? The children who asked me this, Naina and Namita, did you get it?
Yes, sir.
Anybody else not followed this, please ask me, all right? And I want everybody to try and participate in the class. So see if you can ask me a question or suggest something during the question. That's why I keep asking the questions. So I want everybody to feel a part of the class, right? Nobody should feel like they're an outsider. Okay. All right. Anything else? Anyone else?
Sir, could we do 18C43?
C43. I can erase this. Can I? Okay, I'll leave it on for a minute. 18C43 is what you said. Okay. 18C43. Is that the one with the given figure? The figure given below O is the center of the circle and SP is a
Yes, sir.
tangent?
Yes,
Yes,
sir.
sir.
One?
Yes,
Okay.
sir.
All right. So I clear this. Okay. Sometimes, many times, these websites make mistakes. So just let me know if the question's correct. Well, the figure given below, O is the center of the circle and SP is a tangent. If SRT is 65, find the values of X, Y, and Z.
Correct, sir.
All right. So anybody want to chime in with any particular point? Anyone want to say anything? Go ahead.
So can
Can
we
I
say
say that
angle TSP is 90 degrees?
ST is 90 degrees? Yes, indeed, it's 90 degrees. Well done. Yeah, that is 90 degrees. Yeah. Okay. Anybody else? Okay, what would angle STR be? Anyone? STR. That I think is X there, right?
So if you join a line SQ, then you can say that angle SQT is also 90.
So from this triangle, can anyone gather something? 1 minute, Yash, I get your
Yes, sir.
point. Okay. Yeah. So
So
from
is
this,
it 55 degrees?
um, yeah, I mean 90 plus 65 plus the angle X would equal to 180, right? By angle sum property, you have the three angles which would add up to 180 in this. You know that one of the angles is 90, the other is 65, and the other is X. Okay, is that 155 plus X is equal to 180. It would be a little less than 55, right? 180 minus 155, X is 25 degrees. Is that fine?
Yes, sir.
Yes, sir.
So we worked out what X is, and we've said that X is 25. Okay. Anything else? Any other piece of wisdom that anybody wants to share?
The OT is equal to OQ because of radii of the same circle.
OT is equal to OQ, fine.
So angle OQT is equal to angle OTQ.
That's very good, yeah. So one moment, let me just highlight what Yash has just said. So this triangle is what you're referring to, right?
Yes, sir.
So Yash is claiming that this is an isosceles triangle because these two, and this appears many times. Okay, this little fact, if you didn't know it already, guys, any one of you, just please remember this is extremely important. They don't mention it in the theorems, they probably don't even mention it in the chapter. But when you have two radii making a triangle inside the circle, then those two radii obviously are equal, and because they're equal, the corresponding angles will be equal. Okay, so in this case, we prove that x is 25 degrees, which would make this angle also 25 degrees. Okay, so very quickly we are able to work out this. And since we know that these two are 25 each, the third angle, the vertex angle of this isosceles triangle would be 130, right? Is that fine?
Yes, sir. And sir, now RQP is equal to TQO because of this thing, or opposite angles.
That would make, hang on, why that would, 1 minute. This angle now, because it lies on the same straight line, 130 and y, okay, these two angles, 130 and y, lie on the same straight line, so they would be supplementary, right? They would add up to 180. Again, guys, if you are not sure of this, let me know. 130 plus y is equal to 180 because it's a they're called a linear pair. And therefore that would make y as 50 degrees. Okay. They would make y as 50 degrees. So is that fine? So we found our second unknown angle. And lastly, we need to find z. So anybody, for z, I want someone else, someone new to say something out to me.
Sir, in the triangle OSP.
OSP, hang on, just give me a second. I'm a little slow at this. I'm not as quick as you guys speak. So OSP, okay, the blue triangle. All right, what's happening in OSP?
So, sir, we can take 90 degree plus 50 degree equals Z.
90
Plus
plus
Z equals
y plus
180.
z equals 180 degrees. Everybody follow this? The three angles? Okay. Y we worked out as 50 degrees a while ago. So 90 plus 50 plus z is 180 degrees. And that would be 140 plus z is equal to 180 degrees. Z would be equal to 180 degrees minus 140 degrees. Which of course would be 40 degrees. Okay, you can check the answer at the back just to make sure it's okay. Haven't made any calculation blunders. Just even in the exams, just check and double check your answers. People have been known to make silly mistakes. And when you get your paper back from your teacher, after you make your silly mistakes, I think many of you would feel like crying. So the best thing is to check and double check to avoid that situation. Okay. All right. So the doubts are cleared to some extent, right?
Yes, sir.
So make a note of this. And I've got to say, I'm very happy to have all you guys in the class. And like I said, don't hesitate to stop the class, ask me for a doubt, message me, or mail me if there's any doubts. All right. I want to make sure that all you guys do really well in your exams. And we're going to proceed with that thought. And you guys have got to put in the effort as well during the week. Make sure that you practice on the topics that we've studied and do as many sums as you can. And like I said, if any doubt creeps up, let me know. Okay, I hope you guys were all right in the session. Hope you enjoyed the session. If anybody didn't, let me know. We can do something to improve the session next time. Okay, so I'm going to stop sharing and thank you for joining in. Anaria, is it Haishika? Anaria?
Yes, sir.
Haishika. Okay, Anaria, Haishika, Kushali, Mariam, Naina and Namita, Naren, Omnisha, Tanuja, and Yash Agarwal. Thank you so much for coming in and really nice to see you guys. Okay. And is there a topic that you want to work on tomorrow? You want to tell me today itself, or we'll take it on the fly as it comes? Okay, let me know if you guys, we can take it on the fly tomorrow. Come in with your topic of choice.
Sir, sir, could we do statistics tomorrow?
Statistics. Is everybody okay with statistics? Anybody does not want to do statistics and they think they're absolutely perfect with it? Naren, you're
No,
going to
sir. I
say
want to do it. I wanted to do it.
want to. Okay, okay. Everybody else is okay with statistics?
Yes, sir.
Statistics is a
Yes,
longish
sir.
topic. Yeah, we might take more than a session, but we'll do it as best as we can. Okay. So thank you guys once again for coming in, and happy to have you
Thank
guys
you,
in
sir.
class. And the best way to reciprocate this would be to practice a
sir.
lot. All right. There's no substitute for practice. Do as many sums as you can and let me know if there are any doubts. So I'll see you guys. Have a lovely Saturday. Bye bye.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir. Have a
Thank you,
nice
sir.
day.
Thank you,
Yes, sir.
sir.